Integration can be hard, particularly with all the different techniques. We're here to try to make it a bit easier. Did you know that there are some integrals that you can find without doing a ton of work, maybe even do in your head? Take a look at these integrals. We're going to find them very quickly. To do this, we're going to assume that you're pretty good at the chain rule. Otherwise, go do some practice. This is why it's called by recognition or by inspection, because it requires you to see the chain rule. We're reversing the differentiation process. If the derivative of a is b, then the integral of b is a. Alright, let's get into it. Integrate 4x e to the power of x squared with respect to x. First, recognize that 4x is some form of the derivative of x squared. So then you look at this part and ask yourself, what can I differentiate to get something close to 4x e to the x squared? You would differentiate e to the x squared, giving you 2x e to the x squared. Look how close this is to your integral. You just need to multiply both these expressions by 2. The integral of 4x e to the x squared with respect to x is 2e to the x squared plus c. Just like that. Let's look at another one. Integrate e to the power of x times sine of e to the power of x with respect to x. Recognize that e to the x is some form of the derivative of e to the x. In fact, it is the derivative of e to the x. So ask yourself, what can I differentiate to get close to e to the x times sine e to the x? You would differentiate cos e to the x, giving you negative e to the x sine e to the x. You just need to get rid of the negative by multiplying both expressions by -1. So the integral of e to the x sine e to the x with respect to x is negative cos e to the x plus c. Last one, to make sure you get the hang of it, integrate 2x squared over x cubed take 3 with respect to x. Recognize that 2x squared is very close to the derivative of x cubed take 3. This one is a bit harder. Ask yourself, what can I differentiate to get something close to 2x squared on x cubed take 3? You would differentiate ln of x cubed take 3, giving you 3x squared on x cubed take 3. Now to get the 2, you just multiply both expressions by 2/3. The integral of 2x squared on x cubed take 3 with respect to x is 2/3 times ln of x cubed take 3 plus c. You will likely find these types of integrals in a lot of high school calculus textbooks. Let us know in the comments if you found success. If you enjoyed this video, please leave a like and subscribe to our channel so we can help more students improve in mathematics.